All right, we finally made it to example 4. It's been a long journey, but we made it here. And I'm not going to lie, this time my example that I'm doing is a little bit nicer than yours. But I will also possibly show you some things on the calculator if I have time with the video. So same thing is going to start. I actually have 2 curves, but this now says 2 parts, which means when I graph these, it's going to switch kind of like example 2, where at one point cubic is on top and another point the line's on top. So I'm going to again sketch a very quick graph because in these the graph is really just kind of trying to figure out what's on top and what's on bottom before I have to solve to find their points of intersection. So this conveniently for me is a equation of a line. So there's a y-intercept before I go down 1/2. Basically I have a downward sloping line that's a very unstraight line, but it is what it is. And then I'm going to come over here and I've got a cubic, and I'm not going to try to figure out all the roots for this thing, but what I do know is it has a y-intercept of 4 because it's in standard form, and so I'll check that out. There already is one point of intersection. Now this is cubic with a positive lead coefficient, so I know I got to go up and I got to come back down and I got to go back up. So I'm not going to really worry about where it crosses here because I'm not checking this one in relation to the x-axis this time, but I do know that I've got to go up somewhere, turn, come back down, go somewhere, turn, go back up, just based on my end behavior, and I don't have any idea what happened over here. But what I do notice now is I have area 1 here in purple where the cubic is on top of the line. And then over here in St. Patrick's Day green, the line happens to be above the cubic. So I have to have 2 completely separate pieces. That's why this says 2 parts. So now I already know this point of intersection is 0. I have to figure out where these 2 happen to be. So I have to set these 2 equations equal to each other, just like we did on example 3, and figure that out. So if I set x cubed minus 4x squared plus 4 equal to negative 1/2 x plus 4, and I look at this thing and I say to myself, I don't want to add fractions. I don't. It's just a fact. So I'm going to multiply everything by 2 to make this not be a fraction. So this is now 2x cubed minus 8x squared plus 8 equals negative x plus 8. I literally multiplied everything by 2. Now I'm going to move everything over. So I'm going to add the x over here, and I'm going to subtract the 8. So I'm going to have 2x cubed minus 8x squared plus x. And when I subtract the 8, I end up with, oh, well, why didn't somebody tell me this very small mistake that I made? And that is that this is an x, not an x squared. So I will erase that, and I will erase that, and I will come over here. And I can't believe none of you mentioned that to me in class today. So when I add the x over here, I actually do have something to combine it with. So it becomes plus 7x, or sorry, minus 7x. And I subtract 8, and voila, equals 0. This doesn't look very friendly, but I do have a GCF of x. So if I factor an x out of this, I would have 2x squared minus 7 left. And here is my first point of intersection, which is x value 0, which is right there. And this gives me my other 2. So unfortunately, I have to set that separate one equal to 0. So I add 7, divide by 2, and great. My other 2 are plus and minus square root of 7/2. Like it or don't, there's 2 of them. I don't care. I'm going to do what I got to do. So I got to break this into 2 pieces. So the first one I'm going to write in blue because the blue's on top. So the first piece of this is going to be from this point over here, which I'm guessing is the negative 7 rad 2. So from negative square root of 7/2 to the point of intersection right here, where they meet again, is 0. Then on that one, the cubic is on top. So I'm going to have x cubed minus 4x plus 4 minus this line, which is underneath it, negative 1/2 x plus 4. Again, notice, put this dx here to be official. That is going to have to be distributed. Then I'm going to add, because I have a whole second piece here, and I'm changing this one to red because the line's on top, but they start at 0. And it goes up to what again, this point must be the positive square root of 7/2. So that's my upper bound. Line is on top, so I'm going to go negative 1/2 x plus 4 minus, and the cubic function, this whole thing is underneath it, so that's going to be x cubed minus 4x plus 4. That would all have a dx. Whew, that's a lot, but I got these two pieces. One thing to notice that they are balanced in terms of the bounds and in terms of being just opposites of each other. So the idea is, even though my picture doesn't look like it, is these two areas are probably similar. So you can do some absolute valuing if you want, but we're gonna play the whole game out and see if they actually come out to be the same anyway. So I'm gonna combine like terms over here on the left, and I'm gonna have to scroll down in a minute because I ate up a lot of space up top, but that's negative square root of 7/2 to 0, and this is x cubed, has no partner. And if I go minus 4x minus a negative becomes plus, so it'd be minus 4x plus a half, which is 3.5. So I'm going to write minus 7/2 x, and 1 minus 4 becomes minus 3. Why do I can't even read my own handwriting. All right, people. Once again, this 4 is not a 1, it is a 4. So I need to go back because that changes everything. It looked like a 1 to me. I'm going to write it proper, and then I'm going to come back and I'm going to fix this business down here because actually something quite nice happened unexpectedly. 4 minus 4 is gone. That's it. That's the left piece. That's what I'm integrating on the left. Dx plus 0 to positive square root of 7/2, negative 1/2 x. I'm just going to leave in the front for now, but I can't. I lied again. I need to actually look ahead because there's actually like terms to combine here. So negative 1/2 x minus a negative 4 becomes plus 4x. So this is a positive 7/2 x. 4 minus 4 is gone, and minus a negative x cubed means minus x cubed. So you'll notice that these two functions are exact opposites. Opposites of each other in terms of signs, and the bounds are also opposites in terms of signs. So I'm going to give myself a little bit more room here to work, and I'm just going to integrate this guy. So x cubed becomes x 4 over 4 minus, this is going to become x squared, which means I have to divide by 2, but there's already a 2 down there, so it becomes minus 7/4 x squared, which, as far as I'm concerned, might actually help. Hold on a second, I didn't mean to bounce back up. Might help because of the fact that everything's in terms of force. So apparently I wasn't paying attention and I drew my bar there, but I'm going to put this bar here. I'm going to draw extra little segments so I don't get confused. I got to plug in what appears to be a gross value, but I'm not going to worry about it. Plus, I'm going to integrate this. It's basically going to be the same thing, but the opposite. So this is going to become 7/4 x squared minus x4 over 4. And again, my bounds here are 0 to positive rad 7/2. So you may not appreciate the 7/2 under a square root, but I'm not going to worry about it too much. I'm just going to do what I'm supposed to do here. I do like to switch colors every once in a while, so I'm going to do that. So if I put a 0 in here, it's 0. If I put a 0 in here, it's 0. So that first thing is quite nice because it's 0. Minus, I do want to write the 0 because I do have to subtract everything that comes after it, and so I just want to be careful with that. Now if I put in the square root of 7/2 and I raise it to the 4th power, it will basically become 7/2 squared, which is 49/4, and this 4 would make that 49 over 16. So again, just I square, 4th power is squaring twice. So if I square this, it gets rid of the square root and the negative. And I square it again, it becomes 49/4 divided by 4 makes 16. If I put this guy in here, it becomes 49/4, and the negative is gone, right? So again, I put this in here, it becomes 7/2. 7/2 times 7/4 is, I put a subtraction, 49/8. Okay, the negative disappears with the squaring, but that's still a minus. So then I'm going to come over here, I'm going to switch colors just so we're sure what's going on. Plus, I'm going to put in square root of 7/2 in here. I squared it, becomes 7/2. 7/2 times 7/4 is 49/8. Minus, I put it in here. Again, the square makes it 7/2. Squaring again makes it 49/4. Divided by 4 is 49/16. So you're kind of seeing a trend. And then I put 0 in both of these. It's just minus 0. But what I have to do now is make sure that I distribute this negative sign to everything. So this blue part actually becomes 49/16 negative plus 49/8. This plus sign is plus 49/8 and minus 49/16. So I have a lot of pluses and minuses there, but if I were to combine like terms here, these two right here are going to be able to add up to, in essence, let's see, 180. Quick pause because instead I think what I'm going to do is I'm going to turn everything into sixteenths. So negative 49/16 plus, turn that next one, I have to double it, and 49 doubled is 98. I'm going to do the same thing here, so I'm going to have another 98/16, and then I have a minus 49/16. And so what happens is, quite nicely actually, this negative 49/16 and this negative 49/16 make a negative 98/16, so they cancel one of those, and so at the end I just have 98/16, which I know can be reduced by 2 to 49/8, and that is the area between those two curves. All right, gonna check the next one, which is a U-try, and it's definitely gonna be a little bit tougher for you than the one I just did, because I gave you a quadratic and a cubic instead of a line. I switched on you, ha ha ha. Okay, pause video, try it. Don't worry, just try it. Okay, video's unpaused. Here's what you should have gotten. Again, quite an elaborate answer here. I did a very quick sketch, but you could also check this in your calculator and find which one's on top. So the cubic's above quadratic, then quadratic's above cubic. I set them equal to each other. This I did a little synthetic substitution over here, and I found that all of the points of intersection, and then the 2 is where they switch from cubic on top to quadratic on top, but you'll notice cubic on top, quadratic on bottom, and then I have a second piece, quadratic on top, cubic on bottom. And as always, these are a lot of fraction play going on. So then I integrated opposites, notice just opposites in here, and then I plugged in whole lots of fractions, but it looks like most of them ended up being fourths, so it wasn't too horrible down here with your final answer. So again, all of these will be posted in Classroom if you want to take a closer look, or you can always pause, slow down videos, speed them up, fast forward, rewind. It's amazing. All right, that's it. I'm not going to take any more of your time. Hope everything's going well for all of you and you're feeling healthy.